There she is, 150 million kilometers away. The light is absolute. So, science lovers, science questioners, and sports fans alike, we are here because I've been pushed and told that I don't understand the science. So I've been up all night to show that I do know the science. Because I think, well, I know that the light from the sun is absolute. There is no gap, there is no time difference, there is no nothing. I've been told I don't know the science method. I'm tired, I've been up all night. I'm not cranky, but I'm a bit, right? So, I could do with a couple of hours sleep. Some things are more important. So I was up all night, literally. I have not slept. I did some inside stuff, but no, it wasn't going to be enough. So what we've done is we've gone outside to do proper science. But before we go, it's 150 million kilometers from the sun to Earth, right? We can't see it, we're told. The biggest star, Scuti, 2.38 billion kilometers is its diameter. Alexa, what's 2,380,000,000 divided by 1,390,000, please?
This might answer your question. 2.38 billion divided by 1.39 million is approximately 1,712.2302.
1,712. Just to check, Alexa, what is 1,712 times 1,390,000?
1,712 times 1,390,000 is 2,379,680,000.
Close enough. The diameter of Scuti is 1,712 times the diameter of our sun. But we wouldn't see it because the closest edge of those two planets are in the same place, exactly 150 million kilometers away. So if we can't see that, we can't see the biggest star in the universe either. Right, what we did, the truffles can be found at 4.6 kilometers per second. You said I didn't know the science. This is science. What you've said about old Roma is pyramid science. It can't be done. This is planet Earth right there, that little blue. That's planet Earth there and the moon. We are at 8 minutes and 20 seconds away from the sun, which is down there in the red. All right, right here, we've got 108 diameters, sun diameters in between here and the sun. It's 107.9. We made it 108. What I did, remember we have 8 minutes and 20 seconds, all right, for the light to get from the sun. And I said it was 8 minutes times 60 was 400 and what was it? 480. We add the other 20 seconds and we've got 500. There's 400. We've got a bit of a Venus thing going on there. We'll come back to that. Then we've got the 300. These are all sun diameters. So that's 50. I can't see because of the sun. How ironic. And we keep going. And what we have is 15 meters. So I've crammed 150 million kilometers into 15 meters. So anybody who wants to know what the ratio is, the watt to 1, we have got 1 times 10 to the minus 10 power. For those of you that may wonder, because after all, science does overrule common sense. What we have here oh, I'm tired. Alright. Diameter of the sun is 1,390,000. We've got 13.9. Alright. Centimeters. Everything is brought down to the 1 times 10 to the minus 10 power. Okay. Just so happens, science fans, that sun, and I'm not joking, I'm having trouble. Alright? It's going to be good when this lights up tonight, because I'm going to go and get a bulb for it. Alright. Let's go. We are now 150 million kilometers away from Earth, and we're going to head down there. Increments of sun diameters. There are 108 between here and Earth. This is down to scale to probably a millimeter or two out at the most any particular place, right? Sorry about that, I'm tired. I need to go to bed. We are now 30 million kilometers away from the sun. We've got 120 million to go to the left towards Earth. I broke this down into 500 seconds, so it's split into 5. This is the first marker, 100 seconds, 1/5 of the way from the sun going towards planet Earth. Stop. No. We'll carry on. I was going to do something, but I'll do that at the end. I cannot forget. 1 minute and 40 seconds it's taken us to get to here. Remember, this is all to scale. I'm not going to do this right now. I don't think we really need to, do we? This is to scale. It would have taken 4.6 seconds to the sun to go like this. It's 4.6. 4.6 seconds. 4.6 seconds. 4.6 seconds. 4.6 seconds. Just to here, that would have taken 1 minute and 40 seconds or 100 seconds. Now, do we need to say any more? Just in case we do, we're at 30 suns. We get to Mercury. Mercury is 52 million kilometers away from the sun. It's got a diameter of 4,879. It's tiny. We get 109 of our planets in the diameter, for our diameter. Mercury, you can get 284 Mercuries into the diameter of the sun. It takes 88 days to orbit. We orbit in 365. It takes 58 days to spin on its axis once. We spin on our axis every 24 hours. So it's pretty slow. Oh, and it takes light 3 minutes to get here from the sun. We're now at the 200 second mark, so we are 2/5 of the way. It's taking us 3 minutes and 20 seconds to get here. We are 60 million kilometers away, right? And we've got 90 million kilometers to go to get to Earth. 44 suns, 50 sun diameters, and it takes, remember, 4.6 seconds for each diameter. So between this one and this one, there are 5 diameters. All right, 4.6 times 5 is 20. Is that 23? Listen, let's just keep going. 60 diameters, 65. We are now at the 300-second mark, so we're 3/5 of the way. It's taken us 5 minutes to get here. We're now 60 million kilometers away from Earth and 90 away from the sun now. So we're now closer to Earth, right? So what's going on now? We're the speed of light. Earth can't see us from here, or what? How does this work? See how this is impossible? When you do it like this, the truth appears. It'd be good to see somebody get that telescope out and do the proper timing over how many decades? Obviously, if you're going to take it seriously, otherwise it's just pyramid science. Right, we're now at Venus. She's a funny one. She's got a diameter of 12,106 kilometers. So we've got 12,742. We're a little bit bigger than her. 114 of her diameters fit into the sun. 100 of 9 about the 9 houses. The orbit is 225 days. So the orbit around the sun is faster than us. But get this. It takes 243 days for Venus to spin on its axis once, and it's clockwise. So Venus and Neptune are the only 2 planets in our solar system that spin on their axis clockwise, and Venus is so slow, like she orbits the sun faster than she spins on her axis once, and she's going clockwise. That is so slow. Could she be on her way to tidal lock-in? She could have been in that position for a few billion years and slowly slowing down. Who knows, in 100, 200 billion years, she could be tidally locked to the sun, just like our moon is to us. 110 million kilometers to the sun, 40 million to Earth, 75 diameters. 80 diameters, 85. We're now at the 4-minute mark. That's 4/5 of the way, 80% of the way. So what happens now? Let's think. The speed of light, we're still not, it takes 8 minutes, so we still haven't even, we've still got 100 seconds to go to get to the 500. How does that work? Look, we're right here. Huh? So we're just like, we're creeping up on you guys? How does that work? Anyway. This is what everybody wanted, wasn't it? I've been told I don't know the science. Here it is. 105 sun diameters, 106, 107. We are now touchdown. 8 minutes and 20 seconds. Diameter, we know that. I wrote this one down for the science lovers. We spin on our axis once every 24 hours. And this might sound familiar, 365. That's right, days in the year. And then Earth. And we've got the moon there. So that is to scale. This is to scale, right? Tonight, when it gets dark, I'm going to go out and get a bulb for this. Right? And now we've got a little bit of bonus material. I thought, just for kicks and shits and giggles, yeah, it is. We're here now, aren't we? So, what we did, bonus material. We've got Earth at 150. So, I kind of did Earth, like an orbit around the house, isn't it, right? So, we are 150 million kilometers away from the sun. If we turn around that way, guess who that is over there? It's Mars, isn't it? So we're 150 million kilometers away from the sun, Earth. Saying hello, Mars. We're 240 million kilometers away now. This is where, guess who? Come on, guess who? She can't do it, no one can. Ingenuity, she's our man. No, she's our girl. Ingenuity, February 2021. Her and Perseverance, they touched down on the moon together. The pesky duo, we call them. The pesky duo of Mars. Mars, 1.8 years for the orbit around the sun, and it takes 24.6 hours to spin on its axis. So it's a little bit slower than us. Now what is this? Come on sports fans. What is this? I mean, this looks like an ace fighter pilot. 1, 2, 3, 4, 5. Come on, what is it? 6, 7, 8, 9, 10. Come on. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Of course, it's Ingenuity. Ingenuity's flights. 21, 2, 3, 4, 25, 30, 35, 40, 45, 50. Pesky helicopter. 55, 60. Ingenuity. Remote control helicopter that weighs 1.8 kilograms. Is on Mars. It's 240 million kilometers away. 95% carbon dioxide. It's the atmosphere. And only 1% of particles, atoms and molecules. It's nearly a vacuum. Ingenuity, stop being silly. Seriously, come on. All right. The one last piece. We cannot see the sun, they tell us. The speed of light, yada yada, right? So here we are. Bang, all right? So Mars is way over there, remember? You might be able to see her score sheet. Look at you, Ingenuity. All right, so that was from the sun, from here is 240, give or take, million kilometers. Who would come next? Jupiter. So we couldn't go that way. So what I've done, all right, what we did, Jupiter is 743 million kilometers away. We were 150. If we times 150 times 5, we get 750. 5 times the distance to Jupiter. Now get this, right, get this. The sun is there, right? Can you see where this is going? We're over there, right? Another 750 million kilometers, and we can see the sun. Isn't that strange? Right? Because old Roma, Earth would have been in this position, right? Closest to the sun when he took the first reading with his telescope. So we would have been at 150 million kilometers from that sun. We could turn round. If Jupiter's 700, let's call it 750,000, 750 million. Jupiter is 600 million kilometers further out than us, right? This was on our closest, on his closest, right? So he would have been up here looking at Jupiter, but I could only get to that tree and that post over the road. It's 445 million. Still had another 300 million to go past those trees. So it's going to be over the house, right? And just somewhere that is 750 million kilometers. This is to scale, folks. This is to scale. So what they're telling us is that through the telescope, right, he's looking past the sun way out there, right? And he's picking up the reflection of the sun that's going over to Jupiter, and then he's picking it up with the telescope on Jupiter. But why wouldn't he be able to see the sun? All right. I know that the sun is already there, the sunlight is already there, but we're being told it takes 8 minutes and 20 seconds to get to us. So don't even attempt to slide out of this, because there is no way. 743 million, we got to 445, we still had 300 million to go. Oh Roma, you legend. And then on the second one, right, Jupiter would have moved 1/24th of its orbit, because it takes 12 years to orbit the sun. So for our one orbit, Jupiter moves 1/12th of its. But because we only did 1/2 orbit, Jupiter only does a 1/24th. It's in more or less the exact same place. So then, what would have happened with old Roma? He would have waited 6 months, no electricity, no power. He would have probably stored the exact times of when he saw Jupiter pass that house with the, I think it's, right? So he waited 6 months, and when we were at our furthest away, right, but just obviously a little bit of an angle so that he didn't, we don't want to clip that sun, because he would have got his eyes, wouldn't it, with a telescope. So I'd say about here. So now we are 150 million kilometers from the sun. Jupiter is 750, we're calling it 750. So we are a total of 750, 850, 900 million kilometers away from Jupiter. Now, Io orbits Jupiter once every 42 hours. Why should I be doing your job? You do it. Ladies and gentlemen, I know that common sense can never be overruled by science, all right? Now, if you still think it can, what's going to happen now? They're going to just shut the door and throw away the key? They should do, shouldn't they? Who knows, this might not even make it. This might not even make it. I posted it today on Facebook. It's going to go on YouTube, it's going everywhere, all right? I can do the science. Oh, Roma, your turn. We can't see the sun. Huh? It takes 8 minutes and 20 seconds. It's absolute. It's on or it's off. It's nearly a state of mind. I hope I didn't come across too arrogancy, but I have had it up to here with people saying, you idiot. Straight back at you guys. I do get it. You guys said the speed of light is 4.6 kilometers every second. If that hadn't have been there, right, we would have had no idea where to even start to measure the speed of light. But because you put that there, we now know that it's not that. It's absolute. Tonight, I'm going to put that bulb in and we're going to see if it takes 8 minutes and 20 seconds to get to us.